Hello everyone, this is Mr. K, and today we're going to go over the limit definition of a derivative. So whenever you see like a function and it's got a little prime here, that's going to represent a derivative function. So like your original equation that you're using is your f of x, and then the derivative would be f prime of x. And so it's defined as the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And so h is going to be getting infinitely closer to 0, and so you're not allowed to use the substitution method to find this limit because you'd be then divided. You can't substitute in a 0 for h because you'd be dividing by 0. You will also see like a second derivative would be an f with 2 primes or 2 apostrophes. There's third derivatives, fourth derivatives. You can keep taking more and more derivatives. So like, what does this mean? Well, a derivative is also known as the slope of a curve. And you can use this to find the slope at any given point. Notice that the slope, though, can also be written different ways. It can be written as the instantaneous speed. It can be written as instantaneous rate of change. It can be lots of different ways of asking you the same thing. The other thing is that for notation, you'll see f prime of x. There's also ways of writing this as dy over dx, or you might see it as dx of, and they'll give you some sort of equation there. F prime of x, the derivative, dy dx, d dx of some equation, they're all asking you to do the same thing, which is find the derivative. So let's do an example of this. Let's say that our f of x is equal to 2x squared plus 5. And let's say I want to find f prime of x, or find the derivative. So what I want to do is I'm going to write out the limit as h approaches 0 of, now my f of x plus h. What I'm going to do is I'm going to substitute an x plus h into my original equation, so that'll look like 2, and then the quantity x plus h squared plus 5, and now that represents my f of x plus h right here. And now I need to subtract from this, and now it'll be important to use parentheses here. I want to subtract 2x squared plus 5, because that is my f of x. Typically, math, whenever two things are equal to each other, you can substitute in one for the other. So that's what we're doing there. And this is all divided by h. So now comes the simplifying part. Looking right here, in order to simplify this, since it's squared, you need to FOIL it all out or write 2 of them and then do double distributing. So kind of off to the side here, I'll do my 2 and then x plus h, and so now if we're going to FOIL that out, I'll have x times x, which is x squared. I'll have x times h, which is xh. I'll have another xh, and then I'll have an h squared, and that's still all being multiplied by 2. And we still even have this plus 5 kind of just coming along for the ride. So now I can either combine these and get 2xh, and then I can distribute the 2, or I could distribute the 2 first and combine them. It doesn't matter. You should still end up with the same thing, which would be 2x squared plus 4xh plus 2h squared, and then plus 5. And now, if I'm going to go back to now the limit that I'm working with here, I can distribute the subtraction sign, and I've simplified this part, and so we can rewrite this now as the limit as h approaches 0 of, this will be 2x squared plus 4xh plus 2h squared plus 5. And now I'm going to subtract 2x squared and then minus 5 because of the distributing of that subtraction sign. And this is all still divided by h. Now something that you'll notice is that once we start simplifying everything down, you should always be able to get rid of this h. If you can't, then chickadee check yourself because you might have riggedy wrecked yourself. So I see right here I have a 2x squared and subtracting a 2x squared, so those are going to cancel out. I also see that I have a plus 5 here and minus 5 here, so those two are going to cancel out. And so now if I rewrite this, I have the limit as h approaches 0 of 4xh plus 2h squared, and that's still all divided by h. And now here's where the nice stuff really starts to happen, is that now in my numerator I see that both of these have an h, so you can factor that out. And that's going to be the key part here. So now I can rewrite this as the limit as h approaches 0 of h times 4x plus 2h. That's all divided by h, and now those h's can cancel out, and so we're left with 4x plus 2h. And so if I have the limit as h approaches 0 of 4x plus 2h, now we're able to substitute in a 0, and we'll have 2 times 0, which is just 0, and so this is going to just equal 4x. And so what this represents is if I want to find the slope at any given point, all I need to do is substitute in a value into this equation, and I should be able to get the slope at that point. So for example, let's say that I want to find the slope at x equals 5. And we'll say for the equation, or for the function, (2x squared plus 5, because that's what we originally had over here. So then what I can do is I can use my derivative and I can just substitute in a 5. So if I do 4 times 5, I get 20. And so I know that that's going to be the slope of the curve at that point. And I can also use this because it's also going to be my slope of my tangent. That's the instantaneous speed. That's the instantaneous rate of change. So there's lots of different things that this value of 20 represents. But that is how you can use the limit definition of a derivative to find a derivative equation, and then just a quick little application of that derivative equation. Thanks so much. Have a great day.